Okay, we're looking at the 11-5 practice. Wanted to give a walkthrough of this one because this is definitely harder than the previous sections in topic 11. Okay, so we start off with this first question. It's just asking about what is the area of the sector. And that's not the most complicated thing in the world because all we have to do is use the formula. That formula is theta over 360 times pi r squared. Okay, pi r squared, of course, is the area of the whole entire circle. But if we find this fraction, we can just multiply that fraction times the entire area, and it'll give us just the area that's inside of that angle. Okay, inside of that central angle right there. So that sector is going to be with a 170-degree angle. That's what's going to go in place of theta. So 170 over 360. And then when we talk about pi r squared, that's the radius. So it's going to be pi times 9 squared. When we do all of this stuff, we try and simplify as much as we can. 170 over 360, you can do the thing in your calculator, the math frac. All that really does is it turns it into 17 over 36. And then 9 squared is going to turn into 81. So it'll be 81 pi inside of there. So when you multiply all of this out, that gives us 81 pi times 17. If we're keeping our answer in terms of pi, you can see that all of our answers have pi in them, right? So that's going to that's going to make it to where we want to keep our stuff in terms of pi as much as we can. 17 times 81 gives us 1377 pi. On the bottom, we still have that 36. And you can see that's not any of our answers, but what we can do now is divide these numbers. 1377 divided by 36 gives us 38.25. We still have that pi attached to it. So that right there is our final answer, 38.25 pi. Moving on now up to question number 2. Question number 2 is asking the same exact question. What is the area of the sector? So we're going to treat it the same way. We're going to use the same formula. The only difference is going to be our numbers. Okay, theta this time is going to be 50 out of 360. And the radius this time is 6 instead of 9. So that'll be pi times 6 squared. Okay, doing some quick simplifying. 50 over 360 becomes 5 over 36. You also have pi. You also have inside right here, the 6 squared becomes 36 pi right there. And we end up with a really nifty, convenient little thing where on the inside you'd be multiplying times 36 to go across right here, and then dividing by 36 right there. So that actually just completely undoes itself, and all that disappears, and all you have left is 5 times pi, and that's it. Our answer is this one right here, 5 pi. All right, moving into question number 3 is where it gets a little bit difficult because this is where we actually have to start talking about our stuff with triangles. Okay, talking about the stuff with triangles, you can see it's asking what is the area of this blue segment. Okay, this area, this blue chunk of it is what we're looking for. So we start with step number 1. Step number 1 is always to find the area of the whole entire sector. And that's what we were just doing on question number 1 and 2. Okay, we were using that formula, theta over 360 times pi r squared. Okay, and we can find all of those things. Theta is that central angle right there, 120 degrees. So 120 over 360, pi r squared becomes pi times 10 squared. All right, so when we simplify everything down, that becomes 1/3, and that becomes 100 pi. So this right here is going to be the first part of our answer. When we multiply it all out, that becomes 100 pi over 3. Okay, 100 pi over 3. When that gets all simplified down, that's the area of our whole entire sector. So we know that our final answer is going to look something like this. It's going to look like sector area minus triangle area. That's going to be our final answer at the beginning. So this right here is the first part of that. So if the first part of any of these answer choices doesn't start with 100 pi over 3, like this one right here, you can automatically take out this answer choice. You know that one's not going to be right. Okay? Now let's talk about the triangle. Okay, what I'm going to do is I'm going to redraw the triangle, and we'll talk about it. This is very similar to the one that we just did on the notes. Okay, it's got 120 degrees up here, and the two sides or the two legs of this triangle are both 10. Okay, they both represent radiuses of this circle. So both of those legs are going to be 10. And so we know that if we draw a height on this triangle, that's going to turn it in to a 30, 60, 90 triangle. Okay, so I'm looking only at the right side right now. If I'm only looking at this triangle on the right, then this part right here, this shorter leg, is going to be half of the hypotenuse. So that's going to be 5. And this longer leg is going to be the short leg times square root of 3. So that'll be 5 square root of 3. Now here's the thing. We are not just interested in this triangle right here. We are interested in the whole thing all together, right? So we need this triangle that's highlighted in green and this equivalent triangle, this congruent triangle that's highlighted in blue. So what we can do is we can just find the area of this triangle and multiply the whole thing times 2. Okay, that's exactly what we're going to do. We're going to find the area of this triangle on the right. That would be base times height. 1/2 base times height, so 1/2 BH equals 1/2 times the base, 5 square root of 3, times the height, which is 5. Now here's the thing. If we find that right there, this expression represents the area of the triangle on the right. What we can do is just take that whole thing and multiply it all times 2, and that'll give us the area of the whole entire triangle that we're looking for. Okay? So that's what we're going to do. Right at the front of this, you've got 2 times 1/2. That completely undoes itself, right? 2 times 1/2 is just 1. And if you're multiplying times 1, you don't have to write that down. So all we have is 5 square root of 3 times 5. Well, that is 25 square root of 3. So that means the first part of our answer, if our final answer is going to look like sector area minus triangle area, well, we already decided at the beginning that our sector area was 100 pi over 3. And this right here shows us that our triangle area is 25 times square root 3. So we look at our answer choices, and we can see it right down here. 100 pi over 3 minus 25 square root 3. That's what we got. Question number 4. Hoping to get through this in a good, timely manner here. Question number 4. We've got another triangle set up. It's asking us about the blue segment inside of this circle. Okay, so first thing we need to do is find the area of the sector. That's theta over 360 times pi r squared. Well, when we do all of that, that's going to be 60 over 360 times pi r squared is going to be 16 pi. So if we do all of this real quick and simplify everything down, 60 over 360 is 1/6. 16 pi, so times 16 pi, well, that would be equal to 16 pi over 6, or if we wanted to reduce that down, it would be 8 pi over 3. This right here is the first part of our answer. That's going to be important. So when you look at your answer choices, you can very quickly take out this 4 pi over 3 and 4 pi over 3. You automatically know that's not going to be it because your total sector area is 8 pi over 3. Okay, so it's got to be one of these last two. We just got to figure out how much of that area does this triangle take out. Okay, so I'm going to redraw this triangle. This triangle has a 60-degree angle up in there. We know that if this is our 60-degree angle up here, we know that the two legs are 4 and 4 because both of those legs are radii of our circle. That one right there and that one right there. If that is the case, then what we can do is cut this thing in half. Now look at what happens when we cut this thing in half and drop a height down. That becomes a right angle, and that's a right angle. We've cut this 60-degree angle up at the top. We've cut it in half. So what we've done is we've created two triangles that look like this. The angles up in here are 30. The angles down here are right angles. And the only way that could possibly also work is if this is 60. These angles are 60 degrees. Okay, so what that does for us is it makes it to where that's 4 and that's 4, and we have special right triangles. These 30, 60, 90 triangles have special relationships, remember, between the hypotenuse and the legs. Okay, so if you're looking at the hypotenuse right here, that is going to be twice as much as this short leg. So if that's 4, then that means this one is going to be 2, and this one is going to be 2. We also know that the height of this triangle is also related to the short leg. The longer leg of this triangle is the short leg times square root of 3. So that's 2 square root of 3. This other one is also 2 square root of 3. Okay, that's not what we're super concerned about, though, because eventually what we're looking for is to get the total area of this whole entire triangle all together, right? So we can do the area of this triangle times 2, and it'll give us both of them put together. That's what we're going to do. Okay, so 1/2 base times height is the area of a triangle. Well, the base of each of these triangles is 2. Okay, so 1/2 times 2, and the height is 2 times square root of 3. Now, that would give us the area of one of these.
Students and teachers, we are going to stagger release again. Please listen for.
Okay, if we're dealing with finding that this right here is going to find us the area of one of these triangles, but we need both of them put together. So we're going to multiply that times 2, just like we did a second ago. Times 2. Out in the front of this, we've got 2 times 1/2, so all that goes away, and all we're going to be left with is 2 times 2 square root 3. Well, that's going to give us 4 square root 3. So this is the first part right here. This is the second part right here. 8 pi over 3 minus 4 square root of 3. The last problem is one of the easy ones, so it's going to go real quick. The last problem right here is like the easier one that we did at the beginning of the topic 11.5 notes. We start by finding the area of the sector, and it's going to be 90 over 360. It's going to be 90 over 360 times pi r squared, which is going to be pi times 25. So that becomes 1/4 times 25 pi, which is 25 pi over 4. That one's pretty simple, pretty easy. Okay, 25 pi over 4, there's only one option that even has that. It has to be this one right here, all right? That's all we've got for this one. If you do the rest of the problem and figure it out, you can see that the area of this triangle ends up being 25 over 2. 1/2 base times height is 1/2 times 5 times 5, so it's 25 over 2. This one must be our final answer, and that's all we've got for this section of notes. Y'all have a good one.